and of our 75-day LeetCode coding challenge. And today we are going to solve our next problem statement is a subsequence. So let's jump start to the problem statement. Is a subsequence given to string s and t, return true if s is a subsequence of t, or false otherwise. A subsequence of a string is a new string that is formed from the original string by deleting some of the characters without disturbing the relative position of the remaining character. So ACE is a subsequence of A, B, C, D, E if we delete B and D. So, okay. So S is a subsequence of T or not. Basically, if we say A, B, C, D, E, we can say that A and C and E is a subsequence, because if we delete B and D, we can form ACE. Similarly, A, E, C is not an subsequence of A, B, C, D, E, because we have changed the ordering of C and E. If we divide B and D, we can form ACE, but we cannot form AEC, because in this string, always C comes before E, and in this we pass the E before C. So this is not possible to make from this string. So this is not a subsequence. So basically in the subsequence, we can delete some character to form the subsequence, but the ordering should be correct. But if the ordering is not correct, then we cannot make subsequence by deleting any character. So for this ABC, this is A and B and C. So we can delete H, G and D, and we can form this subsequence. So this is true. For AXC, there is no character X in the T. So the subsequence we cannot form. So we are returning false. So let's see how can we solve this problem statement. We have S, that is a subsequence, and we have the T, the string. So we can also say that T length will always should be greater than or equal to S. Correct? T cannot be less than S, because S is the subsequence of T. One thing. And other thing is, what we can do if we have a string ABC, and here we have a string something like A, and let's add some character in between, B, and then add some character in between, and C. We can have two pointer I iterating over the S subsequence, and another index J pointing to the T string, right? We can say if our first character is equal to any character in T, we know that this particular character exists in this string. So let's search character by character. If S of I is equal to S of T, if the particular character exists in the particular character in T, we can say that this particular character exists in this string. So let's say I++, right? And let's increment J every time. So we will keep on incrementing J every time, but we will check if S particular character exists in T or not. And in the end, we just only check if return if I is equal to S dot length or not. Basically, so this pseudo code can solve this problem statement. Basically, for every character, we are just checking if it exists in T or not. If all the character exist in T, just simply return true. If it do not exist, return false. Correct? So let's write this pseudo code in code, and let's try to understand it from there. Let's say we have two index, one I pointing to the S string, and we have a second index pointing to the T string. There can be test cases where subsequence is coming that is greater than T. So to be on the safe, to add defensive programming, we are saying if I should always be less than the I length, s length, and j should always be less than the t length. Execute this while loop. That I should always be less than s length, and j should always be less than t length. We are blindly incrementing j every time because we are iterating over our original string t, and we are saying if our character at ith position, so suppose this first character, ith position is equal to character at j position, so j is pointing to t, so it means that this particular character exists in t. Simply do I plus plus. And check if I is equal to s dot length or not. If it is equal to length, return true. Else return false. Let's do the dry run for it. So for this string only, s is coming as an ABC and t is coming as HHB GDC. I and j value 0. I is equal to 0 and j is equal to 0. This condition satisfied. So first iteration it is true. S dot character is dot t dot character. So I is equal to 0 and j is equal to 0. So this is true. So we increment our I value. I goes to 1. And j also goes to 1. Right? So our new I and j value is I equal to 1 and j is equal to 1. Now again this condition evaluate and it returns true. Now if s dot character at I is equal to, so our second position is b and our second position of j is h. So h is not equal to b. So this condition, for first time it evaluated it true, but for second time it evaluated to false, and j goes incremented j2, so j new value is 2. Again this condition evaluate to return true. S dot character, so now our second position is b and j is equal to 2. So b is equal to b. Now touch time it evaluated to true. I get incremented to 2 and now and j our get also getting incremented. So now our I new value is 2 and j new value is 3. Again this condition get evaluated and it returns true, right? Because I is equal to 2 and the length is 3. Now so I is pointing to C and our j 0, 1, 2, 3 pointing to G. So C is not equal to G. So this condition get evaluated as false. J get incremented to false. So I remains same but J get incremented. Now again this condition get evaluated to true only. And now I is pointing to C and J is pointing to D and C is not equal to D. So this condition again will get evaluated to false. J get increment. So I remain same and J got the value of 5. Now this condition again get evaluated to true. Now now I pointing to the last index and J is also, and C is equal to C, right? So now it evaluated as true and I new value is 3, right? And J also get increment. Now at the last time this condition get evaluated to false and our I is getting incremented, right? Last time. So our I value is 3 and it is equal to the length of the string. So we return true for the test case. So as it successfully run the dry run, let's run our test cases also. So our test case is working. Now let's submit the solution. So yeah, it's working. Thanks for joining the session. Let's meet tomorrow.